Alrighty, welcome to Physical Science. This is going to be an introduction of Chapter 1 in Physical Science. My name is Dr. Malek Abunaemeh, and I'm going to be your instructor for this session. So let me go ahead and share my screen. Wonderful. So we can go ahead and start the objectives of this course, which is going to be identify some base quantities in the system international units. We can also explain different measurement terms, and we're going to be looking at some math skills. So, what is science? Well, science is a process of asking and answering questions. Science is not a collection of facts. Now, there's two types of sciences. You got your life science, which deals with living things, your physical science, which deals with non-living things. Now, when you talk about the scientific methods, we're talking about four steps. The first one is formulating the problem. The second one is observation and experiment. The third one is interpretation, which talks about the hypothesis. And the last one is you test your interpretation. So, for your scientific method, first of all, you start with the statement of the problem. You ask, what is the question being asked of nature? So, what is the question being asked of nature? Once you get to that, then you can go into the second page, the second part, which is going to be your experiment and observation, which is collecting data that been upon the problem that you get from the problem. Next, you're going to interpret the data, which you're going to explain the data in terms of hypothesis about how it works and how it relates to nature and how it works. The last one is testing their interpretation, which predicting the results of new experiments on the basis of the hypothesis. And it goes back in a circle. Now, we talk about hypothesis and theory. So, what are hypotheses and theories? Well, hypothesis is an educated guess that can be tested. A theory is a synthesis of a large body of information encompassing a well tested and verified hypothesis from the experimental observations. Now, an observation can be done without an actual experiment. An experiment is a careful observation that may require recording quantitative information about the observed phenomena. Basically, an experiment is simply manipulating nature and then observing the results. Now, the laws of nature represents our current best understanding. It is subject to change upon additional observations, and it applies everywhere in the universe, from atoms to galaxies. It can be used to predict unknown phenomena and allows us to understand what occurs in places and what can and it allows us to understand what occurs in places we cannot examine directly. So basically, your law tells you what? Your theory tells you why. A theory is more than a hypothesis, is a fully educated guess based on understanding of general principles. Now, when we talk about a model is basically a simplified version of reality. For example, the Earth is a sphere. That's your model. Now, um, scientific knowledge is not frozen. We constantly add to it. Scientists question previous results, and common sense is not a very valid argument when it comes to science. Now, the main thing is when you talk about your science and your results is your unit. So, unit is your physical measurement that consists of a number and a unit, or a standard quantity. Standard quantities such as miles, kilometers, seconds, they're all known as units. Now, the result of each measurement has two parts, the number and the unit. For example, 100 miles, 10 meters, 5 seconds. This is all numbers and units. The main unit that is used outside the United States is international units. Inside the United States, they use the British system. Now, we will be talking about specific units for this course. The main one is going to be your time, which is going to be your seconds. your length, which is going to be your meters. Now your second is going to be, we're going to give it a simple S. Length in meters, we're going to give it the letter M. Your mass is going to be in kilograms, which is going to be in kg. Your amount of substance, later on we're going to see that, is going to be in moles, which is MOL. Your thermodynamic temperature is going to be in kelvins, which is your K. We're also going to be talking about the electrical current, which is your ampere, which is going to be big A. And we get the luminous intensity, which is your candela, which is going to be your CD. Now, why do we use metric? Well, in case if we have a big number, it's going to be hard to write for us. So what we're going to do, we're going to multiply by 10 or divide by 10 for each place. Having that, we can have multiple of base units. Now, the main ones that we're going to be concentrating on is your kilo, which is 10 to the 3 power, which is 1,000. Opposite of it is the milli, which is 10 to the negative 3. You got also your mega, which is 10 to the 6. Opposite of it is going to be 10 to the negative 6, which is your micro. 10 to the ninth is going to be your gigabytes, your giga, and opposite of that will be your nano, which is going to be 10 to the negative 9. Now let's talk about some unit examples. Let me get a new page. All right. Now, when we talk about a kilometer, let's say we have, so let's say we have 1,000 meters. Instead of having 1,000 meters, there's going to be 10 to the 3 meters. Your 10 to the 3, this little fella, this is going to be called your kilo, and you give it a letter K. So instead of writing 1,000 meters, actually, I forgot to put the meters over here. Let me go ahead. 1,000 meters, which is in the 3 meters, you can say 1 kilometer. Now, let's say we have a bigger number. Let's say we have 1,000, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's just use hertz as a sample unit. So, how many zeros you got? 9. So let's say it'd be 10 to the 9 hertz. This 10 to the 9 is going to be called your giga. And this can be written as 1 gigahertz. Let's do one more example, shall we? Let me get a different color. Let's say you have this time 0.001 meters. Actually, let me just go ahead and just write it down, M. Let's say you got 0.001 meters. Now, for this one, you're going to have to move the decimal 3 places. So it goes 1, 2, 3. So it'll be 10 to the negative 3 meters. And 10 to the negative 3, this little fella, this is called your milli. And so you can say this is going to be your 1 millimeter. And this is going to be examples of units. We're going to be seeing more of those as we progress through the chapter. Now, your conversion factors. Your 1 meter is 3.28 foot. Your 1 kilometer is 0.621 miles. Your 1 mile is 1.69 kilometers. And 1 foot is 30.5 centimeters. And a day is 24 hours, 8,600. Let me go ahead and write this down. So, for every 1 meter, it's going to be 3.28 feet. 1 kilometer is going to be 0.621 miles. 1 mile. If you do it in the opposite, it'd be 1.609 kilometers. And 1 foot, let's see, you're talking about feet, it's going to be 30, well, 0.305 meters. And then let's say you talk about 1 day, which is going to be your 24 hours. And it's going to be your 86,400 seconds. Now, notice the different factors. So let's go ahead and do a question on it. So let's say we have a question that would say, how many nanometers is in a kilometer? So that's our question right now. How many nanometers are in a kilometer? So let me go ahead and come over here. Let me write down the question real fast. How many nanometers in a kilometer? So basically, let me get a different color. How much you want? This is your kilometer over here, and this is your nanometers. Again, let me get a different color. Let me get a black color. So again, your kilometer, your kilo, which is going to be your 10 to the 3 power. Your nano, which is your n, this is going to be your 10 to the negative 9 power. So basically what we're talking about is 10 to the 3 meters divided by 10 to the 9 meters. Because we have meters on both sides, on the top and the bottom, we cancel out. And this is going to equal to 10 to 9 plus 3, which is going to equal 10 to the 12. Let's go ahead and check our answer. Yep, it is 10 to the 12. Now, let's do another question. How long is 878 meters in terms of kilometers and in miles? Well, let's do the first one. See, the question is how much you went 878 meters is how much, and I'm just going to use x kilometer, knowing that 1 kilometer is going to be, and again, from the information that we had earlier, where we defined the kilo as 1,000, it'd be what? 1,000 meters. Now, what we do over here, we come in and we cross multiply. So 1,000 times x is 1,000x is going to equal to 878 times 1, which means that x is going to equal to 878 divided by 1,000. That means you move the decimal by three spots, so you get 0.878 kilometer. Awesome. Now let's just do we need to convert it to a mile. Now, knowing that we have 0.878, and I want to convert kilometers, let's say I want to convert that to miles. So down to x mile. And we know that each 1 kilometer is going to be 0.621 miles. And again, you can go ahead and you can cross multiply. And in this case, your x times 1 is going to equal to 0.878 times 0.621. Let me actually write down the 6 better. So therefore, x is going to equal to 0.545 miles. Let's go ahead and check our answer. Yep, we got 0.78 kilometers, which is going to be 0.454 miles. So basically, we can only trust as many output digits as input variables with the fewest digits. If we have a product of 3 or 4 digits number, our results can only have 3 significant figures. It is okay to use more digits in the intermediate steps and then round to the final result. Now, one more thing before we end this chapter, let me go ahead and explain this. So let's say you have a coordinate system. Let me just draw a better one. And in this coordinate system, let's say you have a vector. This vector is v. Now, this vector is going to be resultant of 2 things. Let me get a green. So you got your vector in the x-axis and your vector in the y-axis. I'm going to call this v in the x-axis, v in the y-axis. I'm sorry. And v in the x-axis, whereas this is your y-axis over here, and this is your x-axis over here. And of course, this is going in some kind of angle. This angle I'm going to call theta. Now, let's talk about this little fella, for instance, for a little bit. Now, your sine theta, which is going to be your opposite over hypotenuse. Again, this is your opposite. And this is your hypotenuse, which is whatever on the y-axis over hypotenuse. And we are talking about Vy over V. Again, it's going to equal to sine the angle, which means that this vector in the y direction is going to equal to your vector V times sine theta. Now let's do the one on the bottom. Let's do this little fella. Again, now this is called the adjacent. And I'm going to say AJC, ADJ for it. Now, your cosine theta, in this case, is going to equal to the adjacent over hypotenuse, which is going to be whatever is on your x-axis divided by your hypotenuse. And this is going to equal to V in the x-axis, or V, vector that we called it V, divided by V. And again, this is going to equal to cosine theta, which means that the vector x is going to equal to your V times cosine theta. Now, having from these two, we can talk about our tangent of the angle, which is you're going to be your opposite over adjacent, which is going to be whatever on the y-axis divided by the x-axis, which is going to equal to your Vy over your V of x. That means that angle, we can say, is going to be inverse tan of Vy over V of x. Let me go ahead and write this better. Let me get a different color. So theta is going to equal inverse tan of V of y over V of x. Now let's talk about this vector V for a second. What is this vector going to equal to? Well, using the Pythagorean theorem, P-H-Y-A-G, theorem. Your V squared is going to equal to your whatever V in the x-axis square plus whatever V in the y-axis square, which is going to equal, which means that this vector V that we have is going to equal the square root of Vx squared plus Vy squared. And that should conclude our chapter 1 to introduction to physical science. Again, my name is Malek Abunaemeh. If you have any questions, please email me at abunaemeh@gmail.com. Have a wonderful day.